Alright, welcome back to another episode of PHY 102. This is physics. In this class, I'm talking about the Gauss Law. Right now, under this particular episode, I'm going to be talking about example. In the last video, I explained the application of Gauss Law. So if you have not seen that video, check the recently uploaded videos on Closer's mathematics class and you would see that. All right, so in this particular video, I'm going to be explaining example. Now the first example we have here, please, your focus should be on the first example only, so that you would have a proper understanding of what we are discussing here. So the first example says that what is the electric flux? I think that what is the electric flux through a sphere of radius? You can see through a sphere of radius. So you write your parameters out. The question is, what is the electric flux? So that means I'm looking for what? Phi. I think that I'm looking for my phi, then which consists of what? Radius 4 meter. Radius is what? Radius is 4 meter. Radius is 4 meter, and it consists of what? 50 microcoulombs at its center. That's your Q. Are you seeing that now? Your Q is equal to what? 50 microcoulombs. What does micro means? Micro means times 10 to the power minus 6. Are you seeing that now? So times 10 to the power minus 6. I've already typed that out here already. Are you seeing that now? I've already typed that out. Let me clean this part so that I will make it more clear. All right, so we have our Q. Our Q is what? 5 micro. This micro sign means multiply by what? 10 raised to the power minus 6. Minus 6. All right, so now applying it to our formula. Applying it to our formula, we are going to have, what are we going to have? Now, based on what we have here, if you look at this, is a direct question. This is what? A direct question, and we are looking for phi. So if you look at our application here, you can see that the formula that deals with R, Q, and phi is this our third formula, like I explained in the last video. Are you seeing that now? That is what we are looking into. So, and this formula is like another general formula under the Gauss law. This is another formula under the what? The Gauss law. Are you seeing that now? So phi is equal to what? Q over epsilon naught. Are you seeing that now? Phi equal to what? Q over what? Over epsilon naught. Are you seeing that now? And that will now give you what? What's your Q? Your Q is what? 5. Okay, this is 50. This is 50. Sorry. So that is 50 times 10 raised to the power minus 6 all over what? Epsilon naught is also a constant. I told you in the last video. That is what? 8.85. 8.85 times 10 raised to the power of what? 12. Are you seeing that now? So if you multiply this and divide together, you are going to have phi equal to what? This value you have here, which is 5.649 times 10 to the power what? Power 6. Are you seeing that now? These are direct question on Gauss law. This is a formula under Gauss law. Phi equal to what? Q over what? Epsilon naught. I think that Q over epsilon naught is a formula that you should also know. I think that now is a formula that what you should know. I think that now. So that is our answer for that particular question. All right. So we have another question here. The question 2. The question 2 says that. The question 2 says that a positive charge what? A positive charge for epsilon naught, a positive charge for epsilon naught is surrounded by what? is surrounded by a sphere of radius. So let's write out our parameters again. Don't forget, always write out your parameters. So a point charge, 4 microcoulombs. So Q here is equal to what? 4 micro. That's times 10 power what? Minus 6. Using that times 10 power minus 6 microcoulombs. Let me clean this. 10 raised to power minus 6 microcoulombs. So this is the micro, then coulombs. Are you seeing that now? So with a radius 0.26 meter, so R 0.26 meter. Are you seeing that now? 0.26 meter. Now they now say find the what? The electric flux through the sphere. Find the electric flux through the sphere due to the what? To the distance. Find the electric flux through the sphere through the what? Due to the what? To the distance. Are you seeing that now? So the same formula we used the other time. Now you may be asking yourself, why am I needing this R? You did not use the R because you do not require that in the formula. Are you seeing that? Always work with your formula. You'll be given a lot of values, but you have to use the one that goes with your formula. So our epsilon naught is equal to what? 8.85. By now you should know it. 8.85 times 10 to power what? Power 12. Are you seeing that now? Times 10 to power what? Power 12 Newton meter square per coulomb. That is taking the what? The formula for our what? For our phi. You know, we said our phi in the last video. We said phi is equal to what? Newton meter square over coulomb. Are you seeing that now? Newton meter square per coulomb. So using that now, our formula, which is what? Phi equal to what? Phi equal to Q. Are you seeing that now? Phi is equal to what? Q all over. Let me do that again. Don't forget to subscribe, like, and share this video. So phi is equal to what? Q over what? Epsilon naught. Are you seeing that now? And if you do that, you are going to have what we have here, which is 4 times 10 to the power minus 6 all over what? 8.85 times 10 to the power minus 12. And if you multiply and divide that together, you are going to have 4.52 times 10 raised to power 5 Newton meter square per coulomb. Are you seeing that now? So that is the answer for this second question. All right, so don't forget to subscribe, like, and share this video. If you need a private personal class, a live class with me and you only, you can check me out by sending a message to this number 07052609233. So for any physics course, any topic, any mathematics course, be it 100 level, 200, 300 level, 400 level, master's class, feel free to send a DM to this WhatsApp number. All right, and if you want to have a class for your child, feel free to send a message to that number also. All right, don't go to exam hall feeling unfulfilled. Go to the exam hall feeling fulfilled to be able to write your exam. All right, so we have the last example for today before we wrap up. Now this is the example that shows what we are trying to explain, talking about the application of Gauss law. Now if you look at this question, this is a very, very important question in this course. It says that a large plane sheet has a surface density. What do we call surface density? We say surface density is denoted by what? By rho. Are you seeing that surface density is what? Rho, which is equal to what? Are you seeing that rho is equal to what? Rho is equal to 2.0. Are you seeing that 2.0 times 10 raised to power minus 6 coulomb per meter square. Are you seeing that now? So that is the surface density. Lies in the xy plane. Find the what? The flux. So we want to find phi. Are you seeing that now? You want to find phi of the electric through a circular. Are you seeing that now? So here they are saying through a what? A circular. So this is what we are looking for. So our area now is what? Our A is area of circle. Are you seeing that now? Area of what? Of circle. Are you seeing that now? You can see how I'm breaking it down. So your A is area of circle. Are you seeing that now? Then of radius 1 centimeter. So radius 1 centimeter. You can see radius is also 1 centimeter. That means I have to convert it to what? To meter. Are you seeing that now? I have to convert my what? My centimeter to meter. Alright, so I'm still coming back there. Lying completely in the region X, Y, and Z are all positive and with its normal, making an angle. So angle, making an angle what? Angle 60 degree to the Z axis. So don't forget, you are looking for what? For phi. Are you seeing that now? So if you convert your 1 centimeter to meter by dividing by what? By 100, that will give you 0.001. Are you seeing that now? 0.01. Are you seeing that? That will give us 0.01, not 0.001. 0.01. Are you seeing that now? And if you convert that one to standard form, that will give us 1, 2. Let me do that again. So we have 0.01 by dividing by 100, and I'm sure you know that. So if I'm converting this to standard form, that will give us, if I'm converting to standard form, that will give us 10 to the power minus 2. I'm sure you know. So this is equal to, sorry, so let me just write it here. Our R is now equal to what? 10 to the power minus 2 meter. 10 to the power minus 2 meter. Are you seeing that now? Alright, so let's come here now. So we want to find phi. What's our formula for phi? Our formula for phi under our electric flux, we say phi is the same thing as what? As EA cos theta. Are you seeing that now? EA cos theta. Now let's imagine this question says at angle 90 degree. If the question says at angle 90 degree, there is no need to solve, because at angle 90 degree your answer is going to be what? 0, because anything cos 90 is 0. Are you seeing that now? So if it is 90 degree, it will be 0 directly. Are you seeing that now? So we have EA cos theta. Now what is our A here? Are you seeing that? Our A, before I come to our A, they said a what? A large plane sheet. Are you seeing that now? A large what? A large plane sheet. If you look at the previous video I did, I spoke about that under the application. Now, but let me show you here again, but you need to see that video. So when we talk about large plane sheet, look at it. Large plane sheet. Look at the formula. Are you seeing the formula already for large plane sheet? Where is it? Near a plane sheet. Are you seeing that now? So this is the formula I'm going to use. Are you seeing? This is the formula. So our E in this particular place is what? Epsilon rho over what? 2 epsilon. Are you seeing that? Our E will be what? So if I want to write my formula, I will have what? Phi. Are you seeing that? I will have phi equal to what? E. Our E is what? 2. Are you seeing that now? No, sorry. Our E is what? Rho over what? 2 epsilon naught. Are you seeing that now? 2 epsilon naught. Then our A, you can see our A is what? What did it say in the place? They said circular. Are you seeing that now? Circular area. So our A is what? Area of circle, like I said there. So what's the formula for area of circle? The formula for area of circle is what? Pi r square. Are you seeing that now? Pi r square. That's the formula for area of circle. Are you seeing that now? I hope you are following. Alright. So then what? Multiply by what? So we've written our E, we've written our A. Then multiply by what? Cos theta. Are you seeing that now? Multiply by what? Cos theta. So that is the formula we are going to be using. So let's write that again. Multiply by what? Cos theta. So now I just need to put my parameters now. Are you seeing that now? I need to put my parameters. What will be my parameters? So we have phi equal to, what's my rho? Are you seeing that now? So what is my rho? I can even multiply everything. Let's multiply everything at that top together. So that will give us rho. Are you seeing that? That will give us rho multiplied by what? Pi r square multiplied by what? Cos theta all over what? 2 epsilon naught. Are you seeing that now? So all you just have to do is to put your values now. Once you put your values, you will get your answer. Are you seeing that? So what's your rho? Your rho is what? 2. You can see they gave you the rho here, 2.0 times 10 to the power minus 6. So that's 2.0 times 10 raised to the power minus 6 multiplied by pi. You know our pi is what? 3.14. Are you seeing that? Multiplied by r. What's our r? This is our r, 10 to the power minus 2. So 10 to the power minus 2 is having square. Are you seeing that? Then square. Don't forget the square. Are you seeing that now? Then multiply by what? Cos 60. Are you seeing that now? Multiply by what? Cos 60. You can see the way I'm doing it one after the other. You don't have to rush. Are you seeing that now? You don't have to rush it all over. Are you seeing that now? All over what? 2 multiplied by epsilon naught is a constant. You should know that by now. 8.85 times 10 to the power what? Times 10 to the power minus 12. Are you seeing that now? So that is what we are going to have. So if you multiply together, don't forget phi. This is phi equals to, so that means I'm going to have phi will now be equal to 2.0 times 10 to the power 6. 2.0 times 10 to the power minus 6 multiplied by 3.14 multiplied by 10 to the power minus 2 all squared multiplied by cos 60. So let's do this 2.0 times 10 to the power minus 6 multiplied by 3.14 multiplied by 10 raised to the power minus 2 all squared. If you do that together on your calculator, use your calculator to confirm this answer. That will give you 6.28. So that will give you this value that we have here. This value we have here. So that will give you 6.28. Let me clean this. So this will give you 6.28 times 10 raised to the power minus 10. Are you seeing that? If you multiply those ones together, that's what you will have. Multiplied by cos 60 is 1 over 2. So that one is 0.5. By now you should know what cos 60 means. Alright. All over, if you multiply 2 times 8.85 times 10 to the power minus 12. No, if you multiply 2, what did I write here? I made a mistake here. It's not minus 2. I'm sure you know that by now, that it is minus 12. It is times 10 to the power minus 12. Are you seeing that now? That's your epsilon. So this one is minus 12. Let me rewrite that again. Minus 12. Alright, so that is this one to minus 12 here, please. Alright, so now let's go back to our solution. Don't forget to subscribe, like and share this video. So if you multiply the denominator together, you are going to have 17.7 times 10 raised to power minus 12. So what we did first is multiplying these ones together. Are you seeing that now? Then now your phi will now be equal to 6.28 times 10 raised to power minus 10 multiplied by 0.5. That will now give you 3.14. That will give you 3.14 multiplied by what? 10 raised to power minus 10. Are you seeing that? 10 raised to power minus 10 all over 17.7 times 10 raised to power minus 12. Are you seeing that now? So now if you now divide this, if you divide together, you are going to have, so this is 12. If you now divide this together, you would have 17.74 Newton meter square per coulombs. So this is the answer you are going to have, 17.74 Newton meter square per coulombs. So that is the solution to this question. All right, so if you have any question, feel free to ask in the comment section. All right, feel free to ask any question in the comment section. So don't forget how we started. I told you about the application of the word of the E. So check out for more examples using your browsers. Check out for more example, and don't forget, if you need a personal private class, send a DM to this number, send a direct message to this number, 07052609233, and then I'll be there to have a live section with you. The class is affordable and it's something you are going to enjoy. All right, so this is where we are going to stop our class for today. Don't forget to subscribe, like, and share this video. All right, so thank you very much for watching, and I will see you in the next video. All right.